Alright, let's take a look at number 24. Notice the exponents are starting to get larger and larger. So how do we find critical points? You've got to take a derivative. So the 4 is going to come down, become a 3. 2 times 2 is what? 4. Derivative of 4 is 0. So we end up with something like this. Please don't use this to figure out what your critical points are. You want to factor. I can pull out a 4 from both of them. I can also pull out at most what? An x. Okay, so in other words, if I pull out a 4 and an x, I'm left with x squared minus 1. You don't have to go through the long division. This is just the difference of what? Two perfect squares. So I can write this as 4 times x, x minus 1, x plus 1. Notice now I have three things, well actually 4 things multiplied together to give me 0. This is not 0, so you're going to have what? 3 places for the critical point, which means you're going to have 3 regions, right? So either this is 0, this is 1, or this is negative 1. So if we draw a quick picture, excuse me, we've got 4 regions now. Now remember, the derivative is 0 here, which means if I'm here, the derivative is either positive or negative. Same thing, not the same signs, but the same idea. So now I have to pick what? 4 test points in each of these 4 regions. So I'm probably going to pick who? To the left of negative 1, negative 2. Here I have no choice. How about a negative 1/2? Here, between 0 and 1, 1/2. Here, we're going to choose 2. Alright. So what I do is I put the test points into my derivative. Please do not use the expanded form, use the factored form. Again, I don't care what this number is, except is it positive or is it negative? This guy, the 4 was a positive. Negative 2 is negative. Negative 2 minus 1. Don't tell me what that number is. It's a negative number. And negative 2 plus 1 is a negative number. Don't tell me what the number is. Is it positive or is it negative? So I've got positive, negative means it's negative, means it's what? Decreasing in region 1. Region 2. Now I have to pick a number between negative 1 and excuse me, yeah, so now I have to pick a region in 2. That's between negative 1 and 0, so I put in a negative 1/2 in my factored form. Negative 1/2, negative 1/2. And all I care about is this number positive or negative? Don't tell me what the number is. All I want to know is positive or negative. Obviously negative, negative, and 1/2 minus that is positive. 2 negatives give me positive. Region 3. Now I'm picking between what? 0 and 1. I pick 1/2. You put it into the what? The factored form. So I get positive, because that's positive, negative, positive. That's all I care about. Don't tell me what the number is. So let's see, 3 positives and then negative, which means negative, which means we're what? Decreasing. And then the last one, last region 4, I picked the test point 2. And when I go through the, again, please don't worry about what the number is. Is it positive or is it negative? It's a positive, which means it is increasing. So we could take all this information and put it into our different regions. So it's a negative, it's positive, a negative, positive. So what does that mean? Looks like this is a local what? Min. This looks like it's a local min. Going up, down, up, local min. So where is the function decreasing? It's decreasing here and here. So where is region 1? Everybody from minus infinity up to, but not including negative 1. That's where this comes from. It's decreasing from 0 to 1, but not including, because it's the derivative is 0 there. So it's everybody except 0 and 1. So we say minus infinity to minus 1, or also union 0 to 1. Where is it increasing? From here to here, here to here. So we're going to go from minus 1 to 0, not including those guys, or from 1 to infinity. There's my result. Okay, let's take the next one. Number, what is this, 26? Okay, now remember, we said that, now in all the previous examples, we didn't have to worry about any x's blowing up, but we have right here, remember from day one, I do not want the denominator to be what? 0. So we have a big problem if x is equal to what? 2. Because if I put in a 2, this is 1 over 0. This is not an indeterminate form. This is blowing up, right? So it goes to either positive or negative infinity. So we're not allowed to even look at what happens at x equals 2. Later on, we're going to call this a vertical asymptote. So the first thing we have to do is we have to restrict the domain. We are not allowed to use what? X to be equal to 2. So we have to be this side or this side. We have not even looked at critical points yet. So if I want to take a derivative of this, what do I have to do, guys? Algebra. Bring up the x minus 2 term, raise it to the negative 1. Now take a derivative. So the negative 1 comes down. Minus 1 is negative 2. Chain rule. You have to take the derivative of stuff that's inside. That's simple enough. This is going to be 1. This is going to be 0. So this part is just what, 1. So we're left with this. And if I rewrite that again, so when I bring the exponent down, I have a what? Positive 2. Notice that we have the same problem, that if x is equal to 2, the derivative blows up. Okay, so remember what I said earlier. A critical point is where the derivative is equal to 0, or it blows up. It's not defined. Now, think about this. Do I have any critical points? So in other words, what we're saying is we have the same limitation on the derivative. Okay, let me also talk about one thing real quickly. If I set this equal to 0, I have 1 over who cares. When is a fraction equal to 0? When the numerator is 0. 1, or negative 1, I don't care, is never 0, which means you don't have any what? Critical points in the sense of setting the derivative equal to 0. The only critical point you have here is when it's undefined, which is 2, which turns out to be the same problem as the original problem. So now we just take test points to the left of 2 and to the right of 2. I'm going to pick 0, for example. So a minus, now this is what? When you square a negative number, you're going to get a positive number, but this is going to be negative. Negative 1 over who cares is a negative number, means the function is what? Decreasing. I'm going to pick a nice number to the right of 2. How about 3? 3 minus 2 squared is still a what? Positive number. We have a negative divided by positive. Negative, it means it's what? Decreasing. So what does that say? Everybody from minus infinity up to 2, do not include the 2, or from 2 to positive infinity. Notice we have a peculiar situation. It's negative and then the derivative is negative. Don't assume that if it's negative here, it has to be positive. Not true. Later on, we're going to find out that the graph of this guy actually looks like this. It's going to 0, and it's going to 0. We'll talk about how we get that